This is Lab 2 for Physics 2212, Lines of Charge. For this lab, we used a procedure identical to that of Lab 1. By ripping a piece of tape off another, we created a charged piece of tape that interacted with its surroundings accordingly. I used my model of floating tape from Lab 1 and all my quantitative values again to carry out this experiment. Using what we know about the law of attraction, Newton's second law, and other relevant physics principles, we observed and modeled the physical properties of the tape. In using this knowledge, we aim to create a computational model to accurately predict the charge of the tape. Some relevant physics concepts we utilized were Newton's second law and Coulomb's law. As stated in the second law, we know the force is directly proportional to mass and acceleration, and for this experiment, we assume that the floating tape is motionless, and therefore the net force on the floating tape must equal 0. I also utilized Coulomb's law of electric force between two charges in order to calculate a value of charge for the top tape. For this lab, we can assume that each strip of tape is equal in charge magnitude, and that the charge is distributed evenly across the surface of the tape. We can also assume that air resistance is negligible when acting on the floating tape, and the only forces acting on the floating tape, therefore, are Coulomb's force and gravity. From my Lab 1 procedure, I measured my tape lengths to be 0.2032 meters, my tape mass to be 2.032 times 10 to the negative 4 kilograms, and the distance between the two tapes when the top tape began to float to equal 0.021 meters. To calculate the gravitational force, I used Newton's second law to plug in values for mass and acceleration due to gravity to find that the gravitational force acting on the top tape must equal 1.99 times 10 to the negative 3 newtons acting downwards in the negative y direction. To calculate the electric force, I used Newton's second law and assumed that the net force acting on the tape was 0. Since the only forces acting on the top tape are gravity and electric force, we can assume that the electric force is the negative value of the gravitational force. Therefore, the electric force in this case is equal to 1.99 times 10 to the negative 3 newtons in the positive y direction. Before I begin to calculate the charge of the tape in terms of lines of charge, I want to remind you of the calculation I obtained for the charge tape as calculated in Lab 1, where I considered each piece of tape to equal point charge. Using this method, I obtained a value of 9.87 times 10 to the negative 9 coulombs. And here is the computational model I obtained in Lab 1, where net force equals 0 and the charge of the tape is calculated once more. For Lab 2, we look to obtain a more accurate charge for the tape by considering the tape to be made of lines of charge distributed evenly as opposed to just a point charge. This translates into my code as I first defined the calculation for the electric field of the tape to be the same function as that of Lab 1. However, my code differs now as I coded a function that iterates calculations through each individual charge on the tape to sum up and calculate a more accurate upward electric force. When I used my initial Q value I obtained in Lab 1, my code generated a model that did not have a net force equal to 0. As you can see, the gravitational force is much larger than the electric force, thus proof of an incorrect Q value for the strip of tape due to this unbalanced forces acting on the floating tape. After guessing and checking for a couple iterations, I obtained a Q value for the top tape to equal 2.418865 times 10 to the negative 8 coulombs. Using this value, the forces balance on top of the tape, on the top tape, and generate a net force of 0, thus signaling a more accurate Q value. As I previously observed, the Q value I obtained in Lab 2 is about 2.5 times larger than that I obtained in Lab 1. These estimates differ by means of accuracy. In reality, the charge tape is actually a series of charges distributed across the surface, like we assumed in this lab, as opposed to just a singular point charge. Therefore, the calculation for the charge of the tape in terms of lines of charge will be inherently more accurate than to assume the tapes are only point charges.